Come on! Stupid camera, why won't you just. Alright, screw it. Let's see if I can actually see what's going on. Is it at least working? Okay, good, it is. Just for some reason won't show on my end. That's annoying. Alright. Time to get this done. Alright. Today, I'm going to go over chapter 9.1, sequences and their notations. A sequence is a list of numbers determined by a function where the domain is the natural number. It's positive integers, 1, 2, 3, 4, etc. Now, how do we find this sequence? Well, let's go for this equation here. Oh, that's so much better. F of x equals 3n minus 4. Now, what we learned it as is that this is basically the a sub n is 3n minus 4. So, we're going to go over each number in succession, plop it on into the equation, and how we get the end result. So, 1 into there, 3 minus 4, negative 1. 6 minus 4, 2. 9 minus 4, 5. 12 minus 4, 8. Almost slipped up there. Just for a second. I am very, very tired right now. I do not know why. And 5, 15 minus 4, 11. Now, what's the difference between all these numbers? What is the main thing you notice in this sequence? Well, we look over here and we notice that each one is 3 apart. Add 3 to negative 1, you get 2. Add 3 to e to 2, 5, so on and so forth. That's basically how it works. And it just continues on like this in an infinite sequence, like so. And just because I know I can fit in the number, 3 times 6, 18, minus 4, 14. And it just continues on like this. Each one is 3 apart. Now, I've got to grab the eraser. Please don't just make a mess. Okay, that is very, I'm very happy about this. Normally, when I'm using the whiteboard, the eraser doesn't work. All right. So, next we're going to go over recursive formula. Now, recursive formula is a recursive formula is one that defines the terms of a sequence using previous terms. So, a sub 1 equals 4. And the ace of n equals 3 times the ace of n from the minus 1, the ace of n minus 1. Going to put it in like the parentheses things so that it's quite clear that that's there. Minus whatever number we want to put in here. So I've been going off of my notes for this one, again, partly because I'm so damn tired. I literally was just sitting down 5 seconds ago. Not literally 5 seconds ago. 5-10 minutes ago, and I was like passing out repeatedly. So, you know what? For this, now we're going to diverge a little bit. Let's make this 10. Because why not? Now, how does that change the formula? Well, we've already got our first number. The ace of 1 is equal to 4. Now, I won't lie, because I overthink, I went in, when I first saw something like this, I thought, okay, so the ace of 1, if that equals 4, then that would mean 4 equals 3 times the ace of n of 0 minus 10. Well, actually, in the notes, it's minus 5. So I was like, okay, so what would give us that? So after you get 1, 3 times what would equal 1? Well, the answer to that would easily be 1/3. But that would actually, oh wait, no, that would fit. I overthink things way too much. So the ace of 0 would actually be 1/3. But then it wouldn't really fit into the sequence of what we're going to be getting. So continuing on. So let's go over this quite simply right now. So ace of 2 equals what we've already got up here, ace of 1, 3 times 4 minus 10. All right, so let's change. Let's see what we get. Simple. We get 12 minus 10, and that equals 2. That is the ace of 2. But what about ace of 3? Oh, we'll put it in ace of 1 again. Nope. Whatever we have here is going to be what that number is, but the one previous, because we're doing it by minus 1 in this case. So what we're going to be doing is, instead of putting in 3 times 4 minus 10 equals 2, we are going to get 3 times 2 minus 10. Meaning the ace of 3 would equal, in total, negative 4. Ace of 4. Repeat it again. 3 times what now? Negative 4 minus 10. That gives us negative 12 minus another 10. We get negative, oh, my bad. I was overthinking. I smacked it on up to the time in the 6. Negative 22. Is there a pattern that we see here? let's keep going. Times 5 equals 3 times negative 22 minus 10. Negative 72. I think I've dug my own grave on this one because I'm not exactly seeing too much correlation. But regardless, although I have changed this, and I won't lie, I personally don't understand what the exact difference is between 4 to 2 to 4 to 10, 22 to 22, 72. This is a recursive sequence. I'm just not sure how to define what exactly is defining the distance. Whether that's because I'm tired or not, I'll leave that up to you. So let's go for something a little simpler. Let's go for ace of n equals ace of n minus 1 plus the ace of n minus 2. So what are we going to get for that? Well, first we need to know what the ace of n is. In this case, for simplicity's sake, we're just going to have ace of n be, or rather ace of 1 to be just 1. Okay, so what's ace of 0? I feel a little bit stuck on this, I swear. I don't know if it's just that I'm tired, but every time I feel like I hit a, like I'm just, all right, let's go over this, smack into the whiteboard with my brain. Well, if we're going off of this, that ace of 1 equals 1. So for ace of 2, we have ace of 1, which is 1, plus ace of 0, which we don't know exactly. Well, then what would be ace of 1 if it equals ace of 0 plus ace of negative 1 for it to be 1? Well, this would have to be negative 1. This would have to be 0. Or rather, this would have, one of these would have to be 1 for us to get that. Or 1/2. Doesn't really matter. I swear, I'm just, ugh. I am too tired for this. Back to going to using off the notes. Well, ace of 3 in this case is ace of 2 plus ace of 1, which we already know is 1. But I'm missing a blur. I know how to do this. It's just bite the bullet, get it done. Got a hole in my brain right now. I apologize.
The information is there, but I can't see it. I just see a gap where it should be. Going off of, but let's just say it's 1 plus 1 equals 2. So the end result is that this is 1, this is 1, this is 2. All right, base of 4. Now we actually have something we can work with. Base of 4 equals 2 plus 1. And since we're saying both of these are 1, we've already got the start of our sequence as 1 and 1. And because we've got base of 3 now, 2. Now, ace of 4, 2 plus 1, that's 3. Ace of 5, that would be 3 plus 2. We get 5. Now, do we see a pattern here? Yes, we do. In case it's not clear just yet, ace of 6 equals 5 plus 3, which is 8. Saying it yet? I'm pretty certain you are, but just to make sure, going to put it up to a nice 2-digit number. Ace of 7, not Z, ace of 7 equals 8 plus 5 equals 13. What we have here is what is referred to as a Fibonacci sequence. And if you're not seeing what the pattern is, it's simple. We're not adding or taking away anything from what's going into the sequence. All we're simply doing is adding the previous term to the next term, and so on. Adding the term before and the term we're on together to get the next one. 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. And so on. And it just continues like this. And that is an example of recursive formula, one that defines the terms of a sequence using previous terms. See? Now we're going to go over one last one, which is a personal favorite of mine because it's so simple, it's so obnoxious at the same time in how it functions. We are going to go over factorials. What's a factorial? Well, put a number here. Let's just say number question mark. Slap a little exclamation mark there. Now, what does that mean? It's whatever this number is multiplied by each previous number before it. So, for example, we're going to go for something small because holy hell, when you do a factorial, does it expand so big, just so massive. We're going to do a simple 5 factorial. What's that going to be? Well, what this factorial of 5 equals is 5 times 4 times 3 times 2 times 1. But anything times 1 is whatever it already was. So we're going to smack that one away. We don't need your 1. We know what our end result is going to be without you having to be included. Don't worry, we still love you. You're a good boy. So 5 times 4, easy, 20. 20 times 3, 60. 60 times 2, 100 times 1, because we still love our little boy number 1. It's still 120. So 5 factorial equals 120. Show that to some little kid and they're going to be like, 5's not 120. But if they know multiplication, and you can teach them to count that far, they're going to be like, oh yeah, 5 equals 120. Now, the reason why I'm not going to do a bigger number is for the following reason. Let's go for simply 10. 10 times 9. 90 times 9. I'm going to grab my calculator so I don't have to do all that in my head. I am too tired to brain math right now. I'm actually a little worried that maybe it's not too visible. There. Nice and clearly visible, I hope. I can't see, for some reason, my camera is not appearing on the stream, but it is there, it is working. Oh, never mind. For a minute I thought some people were actually here watching this. So, 90 times 9. We're already at 810. We're already at a triple-digit number for our results, and we aren't even past the first 2 numbers. Times 8. 6,480. From a simple 10 with an exclamation mark, we have now gone 3 numbers down and we're already in the thousands. Times 7. $45,360 times 6. I'm just curious now to see how far it takes until we get to the millions. 272,160 times 5. Well, we can already easily enough do that one. All we need to do is cut whatever this is in half, and then times it by 10, so just add another 0. But my brain is not mathing right now. I am too worn out. I am just too tired today. It took us getting up to 5, and we're only half of the numbers through on the factorial for 10, and we've already hit 1,360,800. Not multiple millions, but enough. So, instead of torturing myself and you further, going on and on with this, we're just going to skip forward. Times 4. 5,443,200 times 3. Gotta check. Yeah, 16,329,600 times 2. 32,659,200. And then times our special little boy 1 who doesn't change anything, but he's still there because he likes that. He likes to contribute. 32,659,200. So 10 factorial, I know I may not be pronouncing the term right, is 32,659,000. $200. We went from multiplying 10 by 9 by 8 by 7 by 6 by 5, 4, 3, 2, 1 to over 32 million from just 10 with an exclamation mark at the end. Honestly, I absolutely love how simply factorials work, but I do not want to be any teacher, any student, any professor having to compute the information of a factorial into any kind of algorithm, any kind of designed for anything, that is just a living hell, in my opinion, for anyone who does math in their head. So I would not recommend it to anyone to do in their head. In my opinion, this is the one time I will say use a calculator. It is not worth the mental anxiety of, did I get that right? No, wait, I didn't carry the 4 at this point. Dang it, now I need to go back. Do we even want to try just 20 factorial? I kind of do, but I am not going to, with my brain not mathing to the point where I can take an equation and remake it and immediately fail to answer it despite having made it and understanding the concepts. My brain has the information there, but I am tired to the point where there are random holes where I should be able to see something. Screw it, I'm going to do it on the calculator quickly. 20 times 19 times 18 times 17. Oh, hey, it's actually pretty similar to, kind of similar to the previous one. Like, it overlaps with 10 times 9 times 8 times 7 when it's 20 times 19 times 18. Cool. Times 16 times 15 times 14 times 13 times 12 times 10. Oh God, it's already gone into decimal points with exponent with to the powers. Let's divide it by 12. Oh no. Divide by 13. Oh no. Calculator doesn't like to say what the real number is after 20 times through, after going over 20 factorial, once it hits after it likes it up to here with calculating it, but the second you have to multiply it by 14, no, it's too big. We're using decimals and to the power of. I'm scared of this number. But even at this point, good God, 3,069,792,000. Just going over the first 5 numbers. And after that, calculators are too scared to use the actually sized number. But if you wanna, times this bad boy by 14. Because the calculator too scared. Calculator says it's 4.2977088 times 10 to the 10th power. It is too scared to say it because it has the space to, but it is too scared to say the actual number. Anyways, that is factorials. A personal favorite in my opinion. I like them. Recursive formula and sequences, as well as their recursives. I'm just glad to have this over and done with. I am going home, and I am going to sleep until tomorrow. Good night, everybody. Oh, wait, no, gotta do it like Yakko Warren. Mwah.
Good night, everybody.